Hello everyone, welcome back to PJ Chen Design. Today's new episode for the PJ Meet the Pro. We have Mathew here. It's been in the jewelry business for 47 years. So he's going to share about his experience specific for the casting today with us. Are you ready? Let's get started. Hi Mathew, thank you being here, sharing with us. It's actually your studio here. So would you like to introduce yourself to my fans?
My name is Mathew and I've been jeweler for 47 years and basically in the industry A to Z.
Okay. So with your experience, what type of a printer, like 3D printer you have used, and what is the pros and cons? You like it or not like it?
I had my first 3D printer 2010. It was an Italian machine. It's called DWS, and I started experimenting with that. I had a very good result with them, and at the same time it was very slow at that time when I purchased it. After 3-4 years later, the new products start coming in the market. Like for example, there is the 3DM printers, which they print wax, and there's the EnvisionTech machines which they print resin. And I've been using right now B9 Creator, which it prints resin, and there is variety of machines out there. For certain application, for flat pieces, I would recommend wax. For rings, again, I would recommend wax. But on certain area, the wax is very fragile. It will break.
Right.
On the resin side, which is the good part of it, you can do whatever you want, shape it, and then you can put it in a casting. So wax printing you cannot carve because it's very, very fragile. I tried basically cast every single item printed with any type of resin. 80% of the resins, they have issue. They have issue either shrinkage issue, air pockets issue, or the individual did not cure the resin correctly. So when you're having burnout, the investment or the item it's coming out from gold is like mushy, like a kind of spongy. That can cause from the curing.
Right.
So it depends where you're sending your wax, who's you're doing your waxes or resin printing. It's basically everybody has a preference. All my experience, I seen the result of it, the wax printing in the flat area, it comes out very clean, very crisp, but there's a disadvantage because you have low resolution of the microns because you have lines, layer lines. So you have to take that in count in order for you to prepare your file. The good thing about the wax printing is that you can get complete detail because in the wax printing you don't have to sprue on every angle. All you need to have just a major sprueing in case if you don't want to work on the casting time to sprue it. Right. So you can save time if you want to do it at the CAD when you're designing it, or you have to once it's printed, you have to add yourself a sprueing area.
For many of my subscribers that are advanced jewelry designer, you probably already know that. But for you that you are new to the 3D printing, the wax printer works different than the resin printer. The resin printer, you got a lot of support. It's more like a sprue looking, more like a post to your object. And the wax printer is supporting material is solid. It's a whole piece on the bottom.
That's right.
And then you will melt it out those material as a supporting material. Then you will have the wax. So in general, the wax surface is much smoother or higher resolution compared to
the higher resolution in the surface, the resin printing has higher resolution.
Oh, okay.
Higher resolution because of the way the printers they work. Let's say you wanna print an item 2 inch by 2 inch or 2 inch by 3 inch. Resin printers, they will not print that because you don't have the table to print that.
Right.
And also when it try to print, it will give you certain area different thickness
Right.
than the certain area. It will not give you 100% flat or solid corners.
Right.
This is with the resin printing, but in the
Okay.
wax printing, you would have perfect corners, symmetrical, everything correct.
Okay.
So that's what I seen in my experiences.
So, is it in general wax printing is more expensive than the resin printing?
Well, it's coming down in the pricing. The way they charge the fees, it depends the size of the file, how big it is. In the resin printing, again, the height of the resin, it makes the pricing. Again, every printer charges different fees.
Okay. So, is most of the vendor charged by the volume or the weight or the printing time?
Printing time.
Okay.
They
so,
do charge printing time and the amount of the height.
Also, the height is quite important, and also the longer it takes, it's get more expensive. Okay, so it's more fragile material, but it can print larger piece, have very nice corner if you have those kind of corner.
Yes.
It can also print more flat surface
Yes.
for the solid scale wax printing.
When you have a resin and you have very tiny initials inside of that cavities, when the caster is doing burnout, investment will expand and shrink back.
Right.
Every item in that ring, in that cavity, will become powder, and it will break off that powder and fly around the ring.
I see. Okay.
So then you have a porosity issue, then the item doesn't come out.
So, can I say if you do have the small text inside of a ring, whether it's your logo or something like that, it's better if it is really thin. It's better to do with the laser engraving.
Correct.
Okay.
Yes.
So it's better doing with laser engraving, which will have a very nice detail, and it's coming up. We're gonna go to see the laser engraving in this facility, but if that is the case, laser engraving will be better than you build the text in the model and try to print. And when it get into the casting, it has the problem for casting because the cast investment does expand and shrink.
That's right.
So now let's get into the topic that everybody wanted to know, the shrinkage issue. So is there a standard size or rule of thumb we can say you need to go from model to to the printing, to the casting, and we're gonna talk about the whole process. But is there any of that set number that people can use? What is the shrinkage for the prototype, from the model to the prototype?
From the model to prototype, let's assume you have an item, you designed it on the screen, and the screen shows the proportionals of all those millimeters.
Right.
Now, it's printed, it's the same thing when it's printed. Now, when it comes to the casting, okay, sometimes what happens when you invest it, it depends what type of investment you are using.
Right.
Okay, what happens once it dries up, already you have certain percentage already shrinking in there because of the drying of the investment. Now, when you have a burnout, when it expands and shrinks, it depends again the investment, how much shrinkage can give you the result.
Right.
So I would say rule of the thumb is, I always say it, keep the original item 5% bigger.
Okay. So
That's what I would recommend.
Okay. So if this is something I'm going to cast and that is 10 millimeter.
Yeah.
From the CAD, I want to do 5% larger. It's because it's going to expand in the casting process, specific for the investment is going to expand and shrink, and that will take up to 5%.
That's right.
And it also depends on what type of the investment you're using. It could be less, could be more, but roughly about 5%.
I would say yes, because
Okay.
that's a safe number.
Okay, so what about if I have some stone setting and without a stone? Let's say if I have a ring and that doesn't have any stone, it's just some like shape and form like that. I don't need to worry about anything, just 3D enlarge 5%?
You have to worry on one issue.
Okay,
Let's assume you have a free-form ring.
right,
On one side of it, it's solid, and the other side of it, it's thinner. It's
Okay.
hollow.
okay,
You gotta make sure, as a designer, that you gotta keep it to certain thickness
okay,
that you wanna file it later on.
Right.
Because if I have thinner, then as a professional, it doesn't look good.
right,
But when I have thicker piece, I have always control to clean it the way I want it and the way it will shape it to the shape that I am looking for. So that way I don't have to add melt metal on it, because once you melt metal, then you have processes on it.
right.
So that is the consideration that
Right.
you have to think about that.
I would say it's better enough than sorry, right?
Absolutely.
Because you always want to have enough work, that metal that you can file, than like not enough and try to solder and deal with the porosity.
That's right.
Okay, great. And then so talking about the thickness, I think that brings in a very good question about thickness. What if I have a design and then I have really thick part, like completely solid, and like hollow part, and then so when the two parts meet together, does it shrink differently on this type of a jewelry, like thicker part shrink more or less compared to a thinner part?
Yes, the
Okay.
thicker part will shrink more.
So typically thicker part will shrink more than the thinner part.
That's right.
So is that like changing the shape, or?
It doesn't change the shape. It's basically the weight of the metal, or the way it's formed inside of the chamber when it's cast. That's the reason. Let's say you have a two-part piece,
Right.
that white gold and yellow gold,
Right.
and there's an area that you want to add. The white gold piece has all prongs on it, and the yellow gold piece has just a solid base.
Right,
And you made two pieces separately.
right,
What my recommendation would be is to have the yellow gold piece a little bit bigger,
uh-huh,
and the white gold piece keep it as is.
right,
So once you lay it in there, you have enough room to work with it.
I see.
So that way you don't have to file it from the white gold piece too much in order for you to lay it inside of that yellow gold part that you want to use it as a ring.
Okay, so that also brings in a question for two-tone design. So if I have two-tone, 14 karat white gold, 14 karat yellow gold, and they are equal volume, I don't have to deal with who gonna shrink most. So I will just do both sides the same way,
Yes,
right?
yes.
But if one side is much thicker, the other side is much thinner, then you need to consider the thicker one's going to shrink more.
That's right.
Great.
That's right.
That's a great piece of information.
Yes.
there. So now that bringing another question, say if I do have a stone. So what we was just talking about is no stone involved. But what if I have a stone? Let's say I'm going to have a solitary, and that's 7 millimeter stone in the center.
7 millimeter stone with 4 prong or 6 prong. Let's say your prongs are 1.5 millimeter. When you lay the stone on top, the CAD is calculating the stone is going to be sitting at a certain height. Make the 6 prong head 7.6 millimeter, so you can drop the stone in there comfortably, so you don't have to cut too much out of the prong so it doesn't get thinner.
What about bezel set? If I have a full bezel, the metals are gonna go all the way around. Let's say I have the emerald cut diamond, and it's 6 by 8, and it's the bezel set all the way around. how much bigger I should edit up for that specific design?
The 6x8, for example, if you're gonna put a bezel, I would say it has to be at least 0.3 to 0.4 millimeter all the way around bigger.
Okay.
Because when you lay emerald cut stone in there, first of all, emerald cut like that, it is very risky to have it, to be set, bezel set, which a lot of people, they like to have that way,
Right.
and they try to work with it, but there's a danger part. The
Right.
angles of the corners, it's different. Now you have an issue and you lay that stone on top of that bezel, it will not fit correctly. When it comes in emerald cut, you have to make sure that there's enough corner
room for it.
for when you lay the stone down.
So what about the mini stone on the ring shank? So let's say I'm going to have a shear prong, like B setting on the ring shank, and I'm going to have 1.5 millimeter stone. Should I, when I'm doing the model, should I increasing the stone size or increasing the space in between the stones?
Stone size.
Stone size.
You have to increase the stone size. Let's assume you have a 1.3 millimeter stone. When you are modeling it, my recommendation is you can do 1.4 millimeter. When it's cast, clean, polished, that stone will become to 1.3 millimeter, so it doesn't touch the stones to each other. So that's upon the person who's designing the ring.
Right.
Some people, they say, well, I'm doing it 1.4 millimeter, but I want to have 1.4 millimeter stones in there. The end result, they will touch each other.
Right, because the shrinkage.
That's right.
What is the rule of thumb, a good number to have, like you want to do in the CAD? What is the gap in between those mini stones?
I would say 0.1 millimeter to 0.2 millimeter. Not every diamond or every stone is proportionally cut 1.2 or 1.3 or 1.5 millimeter. Some of them are cut 1.32, 1.12. It
So
just
not 100% exactly on that specific number. We talk about roughly shrinkage. It depends on the machine, and Matt is sharing his experience with us, but don't take it like, oh, it has to be 5%, right? It's always nice to try with your vendor, seeing what type of a printer they have, do a test before you commit it for the production. Now, back to the production, we talk about from the model to the printer, to the finish, roughly about 5%. But what if I want to make a production and they need a rubber mold, and from the rubber mold to, those additional casting, what am I looking in the way of the shrinkage?
Okay, when you're modeling it for rubber molding or silicone molding, my recommendation is always 10% larger,
Okay.
automatically. Because
So is that 10% including the first 5%, or
yes,
is the total
yes,
15?
total.
Total 10%.
10%.
Okay.
It depends, again, the modeling. But if it's a regular wax print, I would have 10% no problem. But if I have resin, then I would increase to 12%. The reason I am saying 12%, remember, once you cast, clean, polish, already you're taking material out.
Right.
Okay, now once you mold it, mold is taking almost 7% out of that size.
Right.
So you have, let's say the original ring, you want the shank to be 4 millimeter, and you made it 5 millimeter. After the mold, when it's molded and injected, would be 4 millimeter. If that's the application you are looking, then it's the 12% range. That is with the wax. That is with the resin printing. With the wax printing, you don't have to go that far, because you can take from the casting and mold it right away. You don't have to do too much cleaning. So that way you don't have that shrinkage as much as what you want. But in the resin, you have to clean the casting in order for you to take out those heavy print marks. So that's the reason I'm saying 12% on that area.
So depends which one you choose for your 3D printing. So this is the casting process, correct me if I'm wrong. So we're starting from the model right here, and we have the model sending for the printing. For the printing, then we have a casting process, and casting process we have finish process. This is the whole process for the prototype, right? So once you like this prototype, you're gonna make the rubber mold, right?
Yes.
And with the rubber mold, you're gonna inject the wax and have the wax go into the casting. So this is the production process. In between those two processes, different shrinkage.
That's right.
So rule of thumb from the model for the prototype is about 5%. And if you want to make a mass production, you want to consider it's in between 10 to 12%.
That's right.
Depends on what you use for either the wax or the resin printer.
That's right.
So that's today's interview. A lot of you, I know that you are advanced CAD designer or you have experience on the casting. This is based on Mathew's 47 experience. Don't just quote on it and say, hey, Mathew said this is 5%, so I gotta do 5%, right? So this is the experience that he like to share, and really thanks Mathew here to share the experience. And by the way, I didn't pay him anything, and he's really nice, a good friend of mine. I wanted to share that with my fans. So thank you, Mathew.
Thank you very much for allowing me to speak to your audience. Thank you.
All right, so we'll see you next. Bye-bye. You didn't say bye-bye.
Oh, sorry.